Hello, in this video I want to look at percents and their role in sample proportions, which are the p-hats. Okay. Now first, I want you to understand that percent is a rate. And a rate is a number that compares two quantities. Each of those quantities has its own units. All right. So for example, if I say to you, I make $10 per each hour that I work. So that's, the numbers are 10 and 1, and the units are dollars and hours. So you can see the units are different. Now, when I say that I make $10 per hour, that really doesn't tell you how much I earned, nor does it tell you how much I made. So when you're given a rate, you really don't know how much of each quantity there is. You just know how they change with each other. That's it. So for you to know something about the actual quantities, you're going to have to know one or the other quantities. So for example, if I say I worked 12 hours. Well, at that point you can say, oh, 12 hours. Now I know how each hour changes with money. I know that for every 1 hour I earn $10. Ah, there we are. The hours cancel out, and 12 times 10 is 120, and then you've only got dollars. Okay? Or you could say, I earned $200. And again, now that you have one of the quantities, through the rate, I can tell you the other quantity. But in this case, it doesn't matter whether I have $10 per hour or 1 hour for $10, because I could say, well, for every hour of work, I earn $10. So in that case, I would start here with $200, and I would say, oh, $10, and I'd put that in the denominator, is equivalent to 1 hour of work. And that way the units cancel out, and I have 20 divided by 10, I'm sorry, 200 divided by 10 is 20 hours. Okay? So this is what I mean by just knowing the rate doesn't tell me how many hours I worked or how much I earned. Okay? I need one of the quantities along with the rate to determine the other quantity. But at least the rate does tell me how one quantity changes with the other. And that's incredibly important. That's what a percent does. However, a percent is very specific in that it is a special rate. It is a fraction. All right? And so because it's a fraction, essentially it's the part out of the total, or the number of people or objects with a trait out of the total population. Because it's always going to be a true fraction, when it's changed to a decimal, it's a number between 0 and 1. And for those of you who've seen percents that are greater than 100%, which would be the 1, when you change it into percent, and we'll go over that a little bit later in the video, that's because you're actually comparing. So you're saying now, for example, the price of, I don't know, a calculator is 120% of what it was before. Well, you're doing comparison, so that's different. But if I'm just talking about a straight percent, it's always a fraction, and in particular, it's a specific kind of fraction where the denominator is 100. So percents, the reason we use them is because they're more familiar to us. We use them so much, and they're standardized so that the denominator is always 100. That way we get a good feel for things. All right? So let's take a look at, for example, let's say, so in our problems, when we're using sample proportions and we're looking at here, what does the percent mean in the sample proportions? It's the number of people or objects with the trait divided by the total number of people or objects. So for example, if I have here 8 out of 47 people do not carry dental insurance. Well, what that tells me is here when I first start out, I have the trait do not carry dental insurance. So when I make this into a fraction, I have 8 people without dental insurance. So that's the number of people with the trait out of the total population, in this case 47 people. Now the 47 people are people from the population. That means some of those people have the trait and some of them don't. So that means some of these 47 people do not have dental insurance and some of them do have dental insurance. But what we've done is we've isolated just the people who have the trait we're looking for. They don't have dental insurance. Now, if I take 8 out of 47 and I want to make that into a percent, what happens is I'm trying to get it to be a fraction, but where the denominator is 100, right? So what that means is I'm saying 8 out of 47 is equal to some number, that's the percent I'm looking for, out of 100 people. Now normally what you're probably used to is you cross multiply, so you have 8 times 100 equals 47x, and then x is 8 times 100 divided by 47. When you do that, you're going to get 17 and a little bit. So you're going to get x is 17 point blah blah 02. So we're going to say 17. But what that means is, when we come back in here, we say that 8 out of 47 is equal to 17 out of 100. All right? That means that basically 8 out of 47 is 17%. All right? So how did we get there? Well, here's what some people, I don't think some people are told this, but the symbol percent, this little symbol is not decorative. It's pretty, but it's not decorative. It's not its intention. It literally has the value of multiplying by 1 over 100, which is the same thing as dividing by 100. So what happens is when you look at this number, right, and you have here 17 divided by 100, you have 17 divided by 100 is the same as 17 times 1 over 100, but we just said that that's 17, and that little symbol, 1 over 100, is the same thing as percent. Okay, that's what that represents. Now let's take a look at how to work with percents in case if you forgot. Suppose you have, since you now know the symbol, that's the percent symbol, is literally equal to 1 over 100, right? So that means that this is what's true. Okay? If you want to change a decimal to a percent, because you're going to add a percent sign there, what's really happening is you're multiplying by 1 over 100 or dividing by 100, which is the same thing as multiplying by 1 over 100. Since you're going to take your number and you're going to divide by 100, you need to compensate, because when you divide by a number, you're going to make it smaller. So you just made it smaller by a factor of 100. Now you got to make it bigger by a factor of 100 also. So that what that means is if I take in my calculator, let's go ahead and show you here, 8 divided by 47, right? There's your 17, blah, blah, blah. So we'll say 0.17, right? So I have 8 divided by 47 is about, right? 0.17. That's its decimal form. But I want to put that percent sign in there. So what happens, I want to take 0.17, I want to multiply by 100, and I also want to divide by 100, so that I'm not really changing the value of the number, right? These two together is really just multiplying by 1. But now I can say, oh, this 1 over 100, that's the percent symbol. And now I go ahead and make this number go ahead and multiply. But since we have the decimal system, that means if I want to multiply by 100, that's the same thing as moving the decimal over twice, so 10, 100. So really this is 17%. So when I take these two together, that's what gives me the 17. And then this here is the 100. So essentially, if you have a decimal and you want to change it to a percent, just multiply the number by 100, which means move the decimal to the right 2 places, 1, 2, and then you can put the percent sign in there, okay? And now if you want to go the other way, if you want to change a percent to a decimal, so let's say you started out with 17%. There it is as a percent. What that means is you already have this here, which means 17 times 1 over 100, right? That's what that symbol literally means. But that means you're taking this number 17 and dividing by 100. Dividing means you're going to make a number smaller by a factor of 100, which means 2 decimal places. How do you make a number smaller? Here's my decimal place right now, right? Because that's like 17.0%. I need to make it smaller by going 1, 2 to the left, right? So I have 0.17, and then I can drop this. Because in essence, By dropping this, I perform the calculation of dividing by 100, which means moving the decimal to the left 2 places. Okay? Now, just as a representation, if I had said 17%, what does that mean? Well, it means that you have 100 squares, so I have 10 squares this way, 10 squares that way. And so I'm just basically going to shade in 17%. Right, so that's 17%. 17 out of 100, okay? So just to wrap this up then, when you have problems that concern categorical traits, and categorical traits are yes-no traits. You either have the trait or you don't. You either have dental insurance or you don't, things like that. And you're given a sample proportion, how that's going to happen is either you get a straight percent, like in our case we would say, oh here, the percent of people without dental insurance is 17%, right? Like that. Or they'll give you the part over the total. They'll say, oh, P hat is 8 out of 47, and you've got to convert it to 17%. And often, you'll deal with a decimal form while you're doing your calculations, and then only at the very end, if you need to tell your audience something, you'll change it into percent. So pretty much almost all the time, right, this is also the same thing as 0.17. Pretty much all the time when you're doing your calculations, always deal with the decimal form. All right? Thanks so much for listening.